Alright, the domain for any radical, it's got to be bigger than 0. Alright, bigger than or equal to 0. So if I take the square root of negative 1, it doesn't work. If I take the square root of 0, oh, it works. Okay? So whatever's inside of there, 1 over x plus 2x over 3x plus 1 has to be greater than or equal to 0. Alright? Now there's a lot going on. Right now, I know that x cannot equal 0. Do you know why? Not allowed to divide by 0. I know that x cannot equal negative 1/3. If I set this bottom equal to 0 and solve it, right, 3x equals negative 1, so x cannot equal negative 1/3. You good? Now I gotta set the top greater than or equal to 0. But in order to do that, I have to add these two fractions. We're pain in the neck. So this fraction doesn't have a 3x plus 1. This fraction doesn't have an x. So I need to multiply this front fraction by 3x plus 1. So if I multiply bottom by 3x plus 1, guess what? Gotta multiply top by 3x plus 1. This fraction over here, I need to multiply by x. Now they both have 3x plus 1 times x. So that means I have to multiply that by x. So lo and behold, that's going to give me a new fraction. 3x plus 1, x, and 3x plus 1 plus 2x squared. Because 2x times x is 2x squared. And that has to be greater than or equal to 0. So I'm going to rewrite the top as 2x squared plus 3x plus 1. And now I want to factor that and solve it. Now, I don't know if we remember how to factor a leading coefficient. I do a circle and box method, and then see the 2x, I throw the 2x on the bottom and 2x on the bottom. And then I take that middle term 3, I put it in the circle. And then I do 2 times 1, which is 2. I put that in the box. And then 2 divided by 1 is 2. And those are the only two things that multiply to equal 2 and add up to equal 3. So I take those two values, 1 and 2, and put them on top. Now the 2's will simplify, and that's going to give me 1 over x. That's going to factor. So my top will factor into 2x plus 1. See the 2x plus 1, how I get that? And then this is going to factor into x plus 1. All over 3x plus 1 times x. Now, that's greater than or equal to 0. So I'm going to set the top. I know. I'm going to set the top equal to 0. And solve the top. So that means 2x plus 1, I'll let equal 0. And x plus 1, I'll let equal 0. So that's going to be at negative 1/2. And that's going to be at x equals negative 1. So now I have all these values. I have x cannot equal 0. I have x cannot equal negative 1/3. I have x has to be greater than or equal to 0. Or x has to be greater than or equal to negative 1/2. So I'm just going to say equals negative 1/2. And I'm going to say equals negative 1. Now I got to plot those on a line. These values here I got to plot on a line. You lost the factoring. Yeah. Modify 3 on the calculator would generate that. But we got issues. We ain't allowed to modify 3, are we? Nah. Take the degree of the top. What's the degree of the top? What's the degree of the bottom? Then, whatever the leading coefficient is in front of each of those values, you divide them. So now I got to go to a number line. Okay? Now I got to order these from least to greatest. So the smallest one is negative 1. Smallest one is negative 1. That's a closed circle. I got a negative 1 there. Then I think negative 1/3 is smaller than negative 1/2. So the next one's negative 1/2. Negative 1/2. And then I got negative 1/3, which is an open circle. And I got 0, which is an open circle. Now I got to plug stuff in. I already combined this on the other page. So if you want to take this, you see this? Or you can take this, or we can use the original. I'm going to use the original. Go 1 unit to the left. Go 1 unit to the left. And that would be negative 2, wouldn't it? So I'm going to throw negative 2 in here. Alright? So whenever there's an x, I'm going to put a negative 2. That's negative 1/2. That's negative 4. And that's negative 6 plus 1. So that's a negative negative, that's going to be positive. So ready? 4 divided by 5 on your calculator. Minus 0.5. Is it positive or negative? You're allowed to take the square root of a positive. So that means it works. So I can shade this to the left of negative 1. Now I'm just going to assume it doesn't work in that zone, you know what I mean? Because then it wouldn't be a math problem, you know what I mean? Like, it's probably going to be, the answer's probably going to be negative infinity to negative 1 with a bracket, union, right? Then it's going to pick up again somewhere between negative 1/2 and 1/3. So it'll be a bracket, see how it's close? Negative 1/2. It is a math problem, you have to understand that. So negative 1/3, but the negative 1/3 gets an open circle. So it worked there, you know? Then, now, these are nice numbers over here. I bet if we threw in 1, it would work, you know? If If we threw in 1, it would work. And so that would give me a union, open parentheses 0 to infinity. So if I go up there and I throw the 1 in, you're probably going to get a positive, you know, nested in that radical. So if I put a 1 in there, a 1 in there, a 1 in there, that's all positive. So that means I can highlight over there. So you can see, if it were a math problem, that's what the answer would look like. Let me see if that's what she had. Yeah, see it? The hardest part for all parties involved is factoring this and solving it for 0. The bottom part, that concept, that's not allowed to have 0 on the bottom. The bottom part, not allowed to have 0 on the bottom. Alright? The other stuff is fraction manipulation. The arithmetic. Yeah. Yeah. Alright, for this one. That's an x to the first. That's an x squared because it's squared out there. And then that's an x to the first. So that's going to be x squared, x cubed, x to the fourth. X to the fourth looks like a big W. That's an x out there to the first. That's an x in there to the second if I were to FOIL it out. So x to the first plus x to the second is x to the third. X to the first again is x to the fourth. But notice it has this negative, so it's not going to be a big W. It's negative x to the fourth. It's going to be a big M. Now I want to graph it. And just by looking at this thing, I know here, there's a graph at x equals 0. I know right there, there's a graph at x equals 0. I know here, there's a 0 at x equals negative 3. But that one there's a TT, because it's squared. Touch and turn. Multiplicity 2. I know here, there's a 0 at 2. So I have a 0 at 0, I have a 0 at negative 3, but at negative 3, I gotta put a TT there, because it's going to touch and turn. And then at 2, way over here at 2, I have another 0. Now, I know my end behavior is x to the fourth. So it's going to be down on the left, down on the right. See how I aim it away from those 2 endpoints? And then when Gerby had me, I would whistle a Christmas carol. I'll go. Touch and turn. And now I got to turn again somewhere out here. I don't know where. To get through that spot there, I got to aim for that 0 now. And then I come back around, I go through there, and bazinga. And I have all these coordinates. This one at negative 3, 0. This one here at 0, 0. Yep. So what you want to do is factor the top, solve it, find out x equals 1/2, x equals negative 4. The wise thing would have been to write it out as 2x minus 1, x plus 4. And then factor the bottom, x squared minus 16. X squared minus 16 is x plus 4, x minus 4. So I have x minus 4 and x plus 4, and then that means the x plus 4s are going to simplify. If they simplify, that gives you a hole at where that equals 0. X plus 4 equals 0 at negative 4. Take the negative 4 and plug it in. 2 times negative 4 is negative 8. Negative 8 minus 1 is negative 9. Negative 4, plug it in. Minus 4, that's negative 9 over negative 8, or 9/8. So I have a hole at negative 4 comma 9/8. Moving on. To find the y-intercept and the x-intercept, I can do that after this stuff cancels out. See how it cancels out? The x-intercept is going to be located where the top equals 0. So I set that equal to 0, and that's where I get 1/2 0. I let x equal 0, so I put a 0 in for x, a 0 in for x. So if I ignore those, that gives me negative 1/4, which is 0 1/4 is the y-intercept. So much going on, right? So much going on. The vertical asymptote is at x equals 4. So I put a vertical asymptote. Horizontal asymptote, that's the degree of the top is 1, the degree of the bottom is 1. I could have done it over here also, Ryan. Look at this original. Isn't the degree of the top 2, the degree of the bottom 2? They're the same. So the horizontal asymptote is going to be that 2 divided by that 1. Y equals 2. Y equals 2. So I go to y equals 2 and put through a horizontal asymptote. So my hole's at negative 4, 1 and 1/8, 9/8. I have a 1/2 0. I have a 0 1/4. And then I just draw my curve along those asymptotes. It mirrors it over on that side of the asymptote. The domain, that goes to negative infinity forever. And then at negative 4, it's a union with an open circle. Then it goes all the way over here to 4. Again, that's a union with a parenthesis to 4, all the way to infinity. So here we go. The domain is parenthesis, negative infinity to negative 4. Parenthesis, union, picks up again at negative 4 on the other side of that hole. All the way to 4. Then it picks up again at 4 on the other side of that asymptote. Then goes from 4 to infinity. The range starts at negative infinity.